Hi, we're going to go ahead and review for the midterm for Manufacturing 2202. And basically, if we look at the outline of what we need to do here, we're going to first start off by modeling a cap drawing that's already there for you. It's drawing letter A. That's worth 50 points. The second thing we have to do is model a bottle that's going to attach to that cap. And that's again worth 50 points. Then the third part of this test is to actually model, or I should say create an assembly and put the two components together and mate them. That's worth 100 points. And then the final portion is to create a drawing of an assembly. And if we scroll over here, you can actually see this is the drawing that you want to mimic as best as you can, or as close as you can. So we basically have a couple views: section view, detailed view, and an exploded view in isometric mode with some balloons and bill of materials. And these are the balloons. Notice there's no dimensions. This is not a dimensioning class. This is more just test to see how you could construct the models and so on and so forth. Okay, so we begin by taking a look. We're going to first model we'll actually model the bottle first. And the bottles, we could take a look here. If we break it down to its simplest form, it's just a cylinder that's 2.5 inches high, and it's 2 inches in diameter. And then it has the neck, which is a 1/2 inch high and 1.5 inches in diameter. Then the typical radii are 100 thousandths, should be on this edge or corner, as well as here and on the inside edge there. Nothing at the top. And then we'll learn how to shell the bottle out. So let's begin. We first go to File, New, and if you're under the basic, you could go ahead and select Part and hit OK. When you first start this part, it's always a good idea to make sure that you have it properly set up for the specifications. For example, everything should be done in the ANSI standard for this test, so make sure you go to the Options menu at the top, and under Document Properties, make sure the dimensioning standard is set to ANSI, and the units will be set to 3 decimal places, and IPS for inch pound second. You'll have to do that for the part and drawing. Okay, now we select, in this case, to make the bottle, we'll go ahead and select the top plane and start our sketch. I'm going to draw the diameter of the bottle here, and this is only going to be 2.5. I'm sorry, actually that should only be 2 inches. Okay, so basically what we're going to want to do here is once we got that set to 2 inches, if you see this D1, just ignore that for right now. We'll go ahead and go to Features, Extrude Boss, and we want to extrude this 2.5 inches high. Once you have that 2.5 inches high, go ahead and select the top surface with your pointer and go to the Quick Launch Sketch, or go to Sketch up at the top and click on the Sketch tool. Now draw another circle right at the origin, which is your center, and let's dimension that, and that's going to be 1.5. in diameter. Now we go to Features and extrude that 0.5 inches high. The next step is we could go ahead and start adding fillets. Go to the Fillet tool, and the typical radius is 0.1. Select this face here, and then select this corner. Be careful, select the edge, do not select the face. You don't want the little green box, you want the green line and the edge highlighted. If you do select the face, it will fillet the top edge, and we do not want that. Hit Apply. Now the next step is to shell. This is the first time we've shelled in class. What you do is you select the shell tool right up here, set the parameters. In this case it's going to be 100 thousandths, and we can see here the typical wall is 100 thousandths of the drawing. And basically you have to select the faces or face that you want to have opened up or removed, as SolidWorks calls it in this box here. So this top face would be the face we'd want to remove. So be sure to select that and make sure it's in that little box before hitting the green check mark. If you do apply this without selecting this face, what will happen is that it will shell it out, but there will be no openings on the outside, and it will be a thin wall inside, and you just won't know it unless you do a section view. And then if you try and add the shell once again, it will error out because it already is shelled. So be aware of that. Make sure that if you're having problems, look if there's a shell feature in your feature tree right here. If there is and it's correct, then you're fine. But if there is and it's not correct, like if this is a sealed top, you could do two things. You could click on it and edit the feature and then select the top face, or just click on it and hit delete and delete the feature and start over again with the shell tool. Okay, that is it. That is worth 50 points. Make sure you save this. I'm going to save it on my desktop. And now we move on to the next part, which is the cap. So now we go to File, New. Again, select Part. Make sure your tools and options are set up so you are in ANSI and units, IPS, 3 decimal places. Okay, now for the cap, let's go ahead and select the top plane and start a sketch. And let's look at the drawing for a second. Now in the drawing, what we see here is that there's an overall diameter of 1.9. That's this top face here. And then there's a set of ribs that go all the way around it. There's 50 of them at 100 thousandths in diameter, patterned nicely around there. And what you could see actually is that there's a 1.8 inch diameter ledge there that we want to create. So basically the 1.8 inch diameter is what we'll work first on, and then there's a 1.5 inch diameter hole. So we're not going to use the shell tool on the cap. You don't want to do that because it's going to be inconsistent then. So let's go ahead and do this. And it's going to be the height of that 1.8 inch is going to be ½ inch high. So let's do that now. So I just select the circle tool, draw my circle, dimension it at 1.8. And we'll go ahead and extrude that. Just go to Extrude Boss, 0.5. Okay. The next thing we can do is that there's this top ledge. It's 100 thousandths thick, and it rests on top of that ½ inch 1.8 diameter. And it's a diameter of 1.9. So let's put that in next. Select the top face, quick launch sketch here, and draw a circle again at the origin. Make it a little bit larger. Go to Smart Dimension and dimension that at 1.8. I'm sorry, 1.9. Go to Features and extrude it 0.1. The next thing we want to do is go to Fillet. Let's go ahead and put the fillet in. This is the most common mistake people make, is they forget to put the fillet in of 100 thousandths. So to reduce your chance of losing 20 points, make sure you remember that fillet. Okay, the next thing we'll do is we'll select the bottom face. I rotated it, I select the underside, and I'm going to draw in a diameter here of 1.5 for the hole. And if we look at the sheet here, it's 1.5, and it's 0.5 minus 0.1 deep, so 400 thousandths. So we go to Features, and be sure you don't want to do an Extrude Boss, you want to do an Extruded Cut. We want to remove material, so select Extruded Cut, 0.4, and apply it. Last but not least is the array. If you cannot get the array in here, remember, you could continue on with the test and still manage to pass. So don't if you forget how to do the array, don't worry about it, just keep moving, and maybe it will come to you once you finish the rest of the assembly. But I've had several students at times give up right at this point because they can't remember how to do the circular pattern. And unfortunately, it's not that difficult, but it is one of those things that happens. So this is what we do to create this. We select this face, start a sketch, take your circle tool, and glide up and find a quadrant. There we go. And click and drag out a circle. Dimension the circle at 0.1. Another thing you should do is go to select by right clicking. You can select the select tool or hit escape on your keyboard and click on the center point and then hold control and select the origin. The reason for this is, as you can see right now, it's blue. That means if I grabbed it, I could drag it and rotate it around. It's good practice to make sure you fully define your sketches. Let's go with a vertical relationship to lock it in. Now it's ready to extrude. So we go to Features, Extrude Boss, and you can see it's extruding the wrong way. So we just have to hit the reverse switch. That's right here on the top left corner right next to blind. And then instead of blind, let's choose something else. For the reason of, we know that this is about as a ½ inch high, but if a design change comes down the road someday, you might want this to be, instead of 0.5, maybe make it up to next. And up to next will ensure that the design intent of the part has a maintained integrity. In other words, if someone changes it, it doesn't have errors like a little gap distance on one end because you thickened it on one side and you forgot to thicken another thing, in this case the rib. So use up to next, make sure it's switched, and it should look like that in a preview. Hit the green check mark to apply. Okay, to pattern this, under linear pattern there's a little arrow. Hit the arrow down and you'll find circular pattern. Select circular pattern, and then the first thing it looks for is the pattern axis. The pattern axis could be a temporary axis that runs right in the center of any cylindrical object, and the way you could activate that is to go to View and find Temporary Axes and turn it on, and lo and behold, there it is. Or now with SolidWorks 2008, you can actually select an edge of the radial object, and it will know to automatically select that. So you don't even need the temporary axes anymore. But if you are using a previous version, 2008, be aware that you still do need to turn on the temporary axis. But in 2008 or 9, you don't have to. So we can just select this edge, and you can see the pattern already beginning. And we want it spread across 360 degrees. Make sure equal spacing is selected first. And type in an explicit value, or just increase this to 50, and hit the green check mark to apply. And you are done. You can now save this, and that's another 50 points. Okay, the third part of 4 is now we have to start the assembly. So now we could go to File, New, Assembly. Now with the assembly, what we want to do is we want to bring in both parts. It's not a bad idea to activate your origin, or so you could see it and drop the parts into the origin, at least one of the parts, so that it locks in alignment with it. So we could go over here to View and activate Origins if it isn't on already. And then you'll see your origin right in the center. Select one of the parts. In this case, part 1 was my bottle, and I want to drop that in first. Click on it. If you don't see it here, go to Browse and try and search for it. Otherwise, now you can just move the tip of your pointer onto the origin, and it will automatically snap the origin of the part file to the origin of the assembly. And let's insert the other component. Go back to Insert Components and select the second part, which is the cap. In this case, you do not want to lock it into the origin because it will lock in at the base. This one you have to click and drop it floating up the top there. Now we have to mate it. the mate tool is found up here. It's the paperclip. We select it, and what you want to do is select the faces that would be stuck together or touching. In this case, we could select this face here, and then rotate this a little bit, and select the inside face. Be careful, make sure you get the face versus one of these edges that it's picking. See, there's a face. Click on it, and it will mate. Hit the apply or the green check mark to add that. Now in my case, mine is kind of intersecting the part. That's not a problem. Let's scroll out a little bit, grab the part with the left mouse button depressed, drag it up, and release it. Now what we want to do is we want to make sure that this underside face is stuck to the top face of the neck of the bottle. Make sure this blue box over here, if the mate selection is still on, make sure it is on. If not, click on that icon. But make sure this is blank at this time. You could always right click and clear the selection if there's something selected from before. And now you could select the underside face of that cap, and then select this face here at the top. Hit the green check mark to apply. If you select the wrong face, you could always hit this undo button. Remember, there should be a gap distance between the cap, or the bottom of the cap, and this edge flange of the bottle. If they're touching, then it's wrong. Hit the green check mark to apply. Now let's move on to the fourth section. Before we do, in the drawing, it actually shows an exploded view, and it's in isometric mode. Exploded views work this way. You cannot actually explode it inside the drawing. You have to explode it in the assembly file first to have it show in the drawing. So this is what we do. If you look up here under Assembly Tools, you'll find Exploded View. Select the Exploded View icon. If you want to read the instructions, they're very simple. Select Component and then drag the manipulator handle to create the exploded step. This picture is a little misleading. It shows the pointer grabbing the tip of what some have called the rockets, or arrows. In this case, you actually want to drag the shaft of the arrow. The tips don't usually work, so let's see how that functions. We want to move the cap about 2 inches above the surface of the bottle. So we just select it, and we'll get these little manipulator handles, X, Y, and Z. And you just drag in the direction you want. So I'm going to grab the shaft of the rocket and drag it up. And right about there looks pretty good. Hit the green check mark to apply. You don't have to have it exactly 2 inches. This is just a guesstimate. They don't give you the values as to how far you actually moved it. Okay, now that's exploded. After you hit apply, if you want to collapse it for some reason, you could always collapse it by going to the feature tree at the very top here where it says assembly or whatever the name is. Right click and you'll find the option to collapse. To re-explode it, simply click the exploded view again, or you could right click up there once more and you'll find explode as an option. To actually continue editing it, exploded view is the best option. Make sure you save this. The final stage, as we talked, this is the beginning of our drawing. We had to prepare that like that for our drawing, is now to create it. So while the assembly is open, let's go to File, Make Drawing from Assembly. You're going to want to put this on an A landscape size because that's the size printer we have in class. It does support B size, but we don't have the paper in there right now, so make sure you select the landscape and hit OK. Now you can see over on the right hand side you have options for importing different views. Try and make it look just like the drawing. So if we look at the drawing here, we see we have an isometric view exploded, we have a front view and what looks like a bottom view, or a top. So we could actually we could take this and drag it over there and then unfold the bottom, and then we could actually drag off an isometric view just by clicking like that, and then right click or hit escape to complete it. Now with the tip of your pointer, grab the box for the isometric view, and let's take care of that one first. Drag it over to the right, and then while it's still selected, right mouse button click in the view, not on the part, but in the view border, and go to Properties. And in here, embedded in this menu, you'll find an option near the middle, Show an Exploded State. If it's grayed out, that means that somehow you did not explode it initially in your assembly and you have to go back and explode it. Otherwise, you can click on Show an Exploded State, hit OK, and now it should show it in its exploded state. If you did not get that option again, if it's grayed out, you could hold the Control and Tab key and toggle between the different components until you get to the assembly, and then just go to the exploded view and proceed as we saw earlier. So let's go back to the drawing. Control and Tab toggles between these. Okay, the next thing we want to do is we want to make a section view. So for a section view, let's scroll up to this view and go ahead and select the view and then go to View Layout. We'll find Section View there. Zoom up as close as you can and glide up to the bottom edge of the bottle. Don't click yet, but make sure that you get an inference point and then drag straight down. And sometimes you get little inference lines. In my case, I'm not seeing any inference, but I am getting a little symbol to the lower right of my pointer indicating that I am in alignment with the center. So I'm going to click and drag that straight through all the way to the top and even beyond the top, because I don't want it on the edges. Make sure it's not on the edges because it might actually attach itself there and it would look a little unusual. Now with an assembly, you have the section scope. What do you want to include? What do you not want to include? In this case, there's only two parts. There's nothing we want to exclude. I would like you to select auto hatching. Auto hatching changes the hatch pattern per part, so they don't look the same. Don't worry about fasteners. Flip direction. Let's take a look. Actually, it's flipped the opposite direction, so it's not a bad idea to click on flip direction. I'll hit OK though anyway without flipping it, so I could show you the other method as we discussed in class. Now I just drag this off and click to drop it. Now if I need to reverse those arrows, a simple double click on the arrow line, the center line, will reverse it, and then a rebuild up here at the top, or Control B as in boy, will update the view. Now if yours looks a little bit different, it's not necessarily wrong. Your cap might actually be rotated. Sometimes you'll see that this looks solid, and that's because the cap was rotated a little bit differently than what mine was, and perhaps it's sectioning through the center of one of the actual ribs versus I'm at the base of one of the ribs. Okay, the next thing we need to do is create a detail view. The detail view is created using the detail view icon up here under View Layout. We select it, move in the region that you want to create a detail of, like the top right corner here works well. Drag out a small circle encompassing an area, and then drag off by releasing the mouse button. Click to drop it, and make sure the scale is a little bit larger than what you currently have. If it's a different size, or if it's the same size, I would like you to change that and just double click on the text and you could type in whatever value you want. In my case, 1:1 is fine, as this is a half scale, as is, I believe. As we can see at the bottom here, it is typical as a half scale. Alright, the next thing we want to do is we want to go ahead and bring in, let's see, actually, let's take a look here. We need to put a center mark in. Center marks are under annotations. So if you click on annotations, and this is worth points, so make sure you put this on, use the center mark tool. Click on the edge of the diameter of the circle and it will automatically put in the center mark. The next thing is we want to go ahead and add more annotations. We want to add some balloons here. Select the view, and you could do individual balloons or auto balloon it. I'll actually do them individually. Auto balloon is nice, but this is only two parts, so it's not too difficult. Just click on the part. If you click on an edge, you'll get a arrowhead. If you click on the surface of the model, you'll get a point. That's just an ANSI standard. Doesn't matter to me, whichever one you have. Now you'll notice that it started numbering them, and the numbers that they have on them is in the order that the parts were inserted into the assembly. If you recall, the actual first part we entered into the assembly was the bottle. The second part was the cap, and that's the order, and it can be rearranged. The next thing I'd like to do is insert a table, the actual bill of materials. To do this, you have to select any one of the views. Make sure you get a border around it, and then go to Tables. Click on the bottom arrow, and you'll find Bill of Materials. There's two options for bills of materials. You could do an Excel-based or just a standard bill of materials. My suggestion in this case is do the standard bill of materials, or just bill of materials. The Excel-based uses Microsoft Excel, and it adds functionality, but at the same time it adds risk as well. Select bill of materials, and over on the left you have options for it. Just use the defaults and hit the green check mark. Move your pointer over to this corner and it will automatically snap to it as you click. And your parts should show up. We have part 1 and 2, or whatever you name them, either the cap or the bottle, and the quantity of each. And these quantities are accurate. If we were to put in 2 or 3 caps, it would show 2 or 3 caps. It actually recognizes it by when we selected the view, it looks at the parts and creates the table from that view. And the numbers should match, as you can see. This is all automatic. Do not try to create the table by actually drawing it out. I have students do that. That's not the point of this exercise. Okay, now that we have that completed, there's one very important last step that you need to add, and that's your name. And that's just done under the Annotations toolbar. Note. Select it, click where you want to drop it over here, and make sure you put in your full name. I don't want initials or the drawn by whatever. I don't, just the full name. Click to drop it, and then hit the green check mark. And make sure you save this, and then just go to File, Print, and you're going to go ahead and make sure you select whatever printer is available in the room. Hit OK, and hand it in, and that should be it. And that concludes the Manufacturing 2202 midterm.